So we're going to look at some examples and why it ends up being that the acute angles are going to have sine, cosine, and tan of all positive, and why the obtuse angles, they're going to end up having positive sine but negative cosine and tan. Okay? So these examples are going to help us with the why. Okay? So remember that we said angles in the first quadrant, they're going to end up being acute, right? Less than 9. Okay, so I have a point xy and it's in quadrant 1. Then angle A is an acute angle which is between 0 and 9. Use SOHCAHTOA to define each trig ratios. Now instead of just using point x and y, I'm going to add to it, like I'm going to give you a point value. I feel like with numbers, it makes it easier for you guys to see, right? So if I have the point to be, let's make the point 3 and 4. So, oh no. Okay. Sorry. That looks so weird. Anyway, let's make the point 3, 4. Okay? So we're going to look at that point. So I have 1, 2, 3. 1, 2, 3, 4. So my point is right here. Okay? Now, we need to form a triangle because we know triangles, sine, cosine, it's opposite. When I do SOHCAHTOA, it's the opposite over the hypotenuse, adjacent over the hypotenuse, and opposite over adjacent. So I need a triangle, right? So this is very important, and this is where a lot of the students mess up. Okay? Listen. So I have my point. In order to make my triangle, first of all, I have to draw my terminal arm. My terminal arm has to always be from the origin to the point. Okay? So my terminal arm is from the origin always to the point.
How people mess up, miss?
In the next step. So, to draw the triangle, because you need to draw a triangle, you always have to draw the triangle with the x-axis. So I can't draw the triangle from the P to the Y, okay? I have to draw the triangle going down to the x-axis, okay? So you see right now, I have a triangle. You see that triangle? Or let me use a different. So I have the triangle, right? And I know it's a 90-degree triangle, right? So let's look at this lovely triangle. What do I know? I know that my point here had values of 3, 4, right? So out of this triangle, if you look at this side right here, what's the length of this side? 3, right? The length of this side is 3 because I know I had to go 1, 2, 3. So the length of this side is 3. And that's the same thing as the x value of the point, right? So that's the x value of the point. Now, what's the length of the vertical line?
4.
That's 4. And that's the same thing as your y value, right? Okay. Now, do I know the length of that longer side from the origin to the point?
No.
I don't know, but that's the hypotenuse, right? So if I draw that triangle, I have this. I have this is 3, this is 4. I know this is 90 degrees. So I know two sides, I'm looking for the third, right? That's my hypotenuse. How can I find my hypotenuse?
The theta sign.
What do we call it? What?
The theta sign where the terminal arm is.
Okay, so that's my theta sign. Now, how do I find the length of my hypotenuse?
3 squared plus 4 squared.
What do we call that term? What do we call that? Pythagorean theorem. So I have to use my Pythagorean theorem to find my hypotenuse. Okay? So you can call it a squared, you can call it r squared, you can call it whatever you want. We usually call, in this unit, we start calling them R because technically speaking, what we have here, in the unit circle, we draw a circle and this is the radius of the circle. So get used to the new terminology. So we call this R, okay? So that's gonna be R squared equal to 3 squared, which is my plus, okay? It's the same thing as the formula of A squared equal B squared to C squared, but we're using different letters now, okay? So to find R, I have to square 3 squared plus 4 squared. So that's going to be 9 plus 16. And that's going to be R squared equal to 25. So that means my radius is equal to 5. Perfect. Okay, so now I know all my sides inside the triangle, right? I know that the base or my adjacent, if you want, is 3, my opposite is 4, and my hypotenuse is 5. Remember that this is your angle of interest. This right here from the x-axis to your terminal arm. This is your angle of interest, right? It's always measured from the x-axis to your terminal arm, okay? So, theta is my angle of interest. Where's my opposite?
4.
4. Where's my adjacent?
3.
And then I know R is my hypotenuse. Okay. Now, what is sine angle theta? What's the formula?
Opposite over hypotenuse.
Opposite over hypotenuse. What letter do I use for the opposite? My opposite is the y value of the point, right? So that's y over, what did I use for the hypotenuse? R. And the value for it is 4 over 5. Is that positive value?
Positive.
That's positive, right? Good. Now, how about cosine? What's the formula for cosine?
Miss Sawel, will you divide that 4 over 5?
Adjacent,
What? Just leave
adjacent
it as
over
well.
hypotenuse.
Adjacent
Hypotenuse.
over hypotenuse. And what letter did I use for the adjacent? X, because that's the x value of my point, right? Over R. So in this case, it's 3 over 5.
Cosine tan negative.
Again, is it positive?
Yes.
Cosine tan negative is our cosine tan negative, right?
In the first quadrant? In acute
No,
angles?
It's positive.
It's going to be positive, right? And that's, you see, positive, right? How about tan?
For
Y over X.
Opposite over
adjacent.
adjacent, which is y over x, and that's going to be 4 over
3.
3. So you notice that all my sine, cosine, and my tan, they all turn out to be positive. Okay? Now, remember that the y over r, x over r, y over x, they're going to be always that for sine, cosine, and tan, especially if I'm given a point in a quadrant, an x and y. So whenever they give you a point, right, you can always use these formulas to find your sine theta, cosine theta, and tan theta. Or you can go the old-fashioned way and draw the triangle, label them as opposite hypotenuse, and then do it. Okay? So you can always go back to the old-fashioned way. This is the new formula that relates to x and y without even drawing the triangle. I can actually look at my point, x and y, right? And I can go, okay, sine theta, that's y over r, so that's going to be 4 over 5. Okay? I can go cosine theta is x over r. X is 3 over 5. Okay? Without even drawing, without even doing anything. Right? So you can get used to these new formulas. Okay, so again, we noticed we did get all positive answers for all the sine, cosine, and any questions about this? Now,
you an angle and a point.
They give you an angle, not at a point,
And a point.
and a point. You can figure out what the angle is, can't you?
Yeah.
What can you do to
Right,
figure out
two
what the
sides
angle is?
already miss.
What can you do to figure out the angle?
Divided and inverse.
Invert, right? Pick any of them.
Yes,
And
miss,
you-
but my question is,
Yeah.
what if
What if?
in the question
Yeah,
they give you a point,
yeah,
and with the point they give you an angle?
okay.
You can like they set up questions like that?
There will be too much information, like you don't need all of them,
Oh.
right? Because they give you a point, that means they already give you the opposite. They won't give you everything.
Okay.
They will give you either the angle and part of the point, or they give you the whole point and they ask you to find the angle. Okay? So in this case, I can ask you, what's angle theta? Right? That's in addition to the question. Right? I can ask you, what's your angle? What do you do to find the angle? Sine inverse, cos inverse, tan inverse, whatever. Right? You have all three of them. Pick one and do the inverse. Okay? Do it. What do you get? Do cos inverse, sine inverse.
Sine inverse of 4.
Sine inverse, yeah, of 53 degrees.
1.
Okay,
No,
so that means my angle theta is 53 degrees. It's acute, right? It's acute. Now, if I ask you, on top of this would be your principal angle. Okay, now I'm adding more information. Principal angle is 53 degrees. Okay? Now, if I want to ask you, what is your supplementary? Is it going to be an obtuse angle? What is your supplementary obtuse angle? What do you do?
-53.
180
About
minus
80,
53. Yeah. Yeah. So if I ask you on top of this, I tell you find the supplementary obtuse, right? Because it has to be obtuse because this one is acute angle. Then it's going to be 180 minus 53, which is what?
127.
Right? So you see how questions can be built up. But for now, that was not my intent, but that's a good thing. We added extra stuff. My intent was to show you that sine, cosine, and tan in the first quadrant are going to end up being positive. Okay. Let's look at why is it negative. Some of them are negative for the obtuse.
I sharpen my pencil before you say.
Yeah. So, we're going to look at a point in quadrant 2. So for quadrant 2, I'm going to pick the point. For it to be in quadrant 2,
Should we draw this table?
yeah. In quadrant 2, so it's going to be,
Oh.
so the x is going to have to be negative, and the y is going to have to be positive. Okay? Because I'm in the second quadrant, x is negative, y is positive, right? So I'm giving you the point negative 3, 4. So negative 1, negative 2, negative 3, and 4. So my point is going to be right here. Okay? Now, to draw the triangle, I have to go from the origin to the point. That's my terminal arm. Okay? Now, how do I draw my triangle?
Down.
Down. Down to the x-axis. Right? We always draw it down to the x-axis.
That's what people mess up, miss?
Yes. Because I don't know why they like to draw it this way. Okay, so now you see, here's my triangle, right? I have this, right? You see my blue triangle, right? Now, where is my principal angle? Where do I measure from?
The far right.
So I have to measure from the
Right.
positive x-axis all the way to the terminal arm. That's called my principal angle. In this case, my principal angle is obtuse or acute? Obtuse, right? So my principal angle is obtuse. This is my principal angle. This is my principal angle, right? I probably spelling principal wrong, I don't know.
Right. No, Ellie is Ellie, right? But that's principal.
I don't know. Is it Ellie?
Principal is Ellie, yes.
Yeah. I keep messing these two up. Francis. Yeah, but
What point does it have to start from when we get started?
doesn't matter, it's just because you're measuring an angle. It's not, you're not measuring from a certain point, right? When you're measuring an angle, you have this thing, the protractor, right?
Oh, yeah.
So it doesn't matter, like as long as you put your protractor here, right? And then you measure it. But we don't
you have
use
to
that.
start from the origin, right?
Yes.
the
So you put your protractor, the origin goes in the middle, the middle of the protractor is gonna go here with, starting from the x-axis, right? And then you're gonna measure your angle. I wish I had one.
You too.
No,
Wait, you too. I remember.
I wish I have a big one.
Oh.
You don't need to. We do most of our math with calculation and not drawing. Okay,
Three-step
so
math.
principal, my principal angle is an obtuse angle. Okay? Now the angle inside the triangle, it's my acute angle, right? It's my supplementary acute angle. Okay? So this is the angle in my triangle, but we know that supplementary angles are going to give me the same value. Some of them are going to be positive, some of them are going to be negative. Okay? Now, where is the opposite?
across.
Across, which is how big is it? 4, and that's my y value, and that's called my opposite. So you see how much information I'm adding to this? Okay? Now I'm not only adding the value, I'm also adding that it's my opposite and it's my y value. Okay? Just because now I know too many formulas, right? I can pick which one I want to use. What's my, where's my adjacent? So my adjacent is right here, and it's -3, and it's my x value. Okay, do I know what my hypotenuse is? Okay, can I find it? Okay, r squared equal, okay? So what's -3 squared plus 4 squared? 9. What, -3 squared is
It's
going
a
to give you,
positive 9.
it's a +9 plus 60. Okay? So -3 squared, because it's negative times negative, it's a positive. So that's going to be exactly the same, right? So that's going to be 5. Okay. Now, sine theta. What did we say sine theta was with respect to x and y and r? Sine theta was what? Opposite over hypotenuse, which is y over r, right? Which is 4 over 5. So is this positive or negative? How about cosine theta? What was the value for cosine theta? What was the formula? What was the formula? It was x over r. What's the value of x? -3 over
that one there, 5.
over 5. Cosine is what in this case? Positive or negative?
Negative.
Negative. Did I know that? Yes. Because I knew that my obtuse angle is going to give me a cosine of negative. Guess what? Because x is negative, I'm proving it to you that yes, when it's the obtuse, right, my cosine ratio is going to end up being negative. How about 10?
Y over X.
Y over
10 is
negative
y over
x.
x. It's not negative x, it's
Oh,
y over
x.
x. Okay? It's y over x, and my y value is,
4,
my x value is
negative 3.
negative 3. Is that negative ratio or positive ratio?
Negative.
It's a negative, right?
When it's asking to like find
Oh.
the angle, you
Yep.
have to like follow through and divide
All of
it.
them are the same except for sign.
the other
Like
question
cos and
says
tan
to
will be
find
both
the
negative, but sin will still be positive.
Angle.
So,
No.
you can, or you can just enter it as a 4 over 5.
But remember,
That's
she
what I'm
was sure
asking.
Yeah, you can do either way.
And then that's what I'm saying. So we don't leave it like this, we like actually like divide it.
You
or
can,
like-
you can, it doesn't matter.
Oh yeah.
It does not.
It doesn't matter.
Okay, now, these are my ratios. Does this prove to you that for obtuse angles, I'm gonna have negative ratio, cosine ratio, and negative tan ratio? Does that prove to you? Is that gonna always be the case for obtuse angles? Yes, because for obtuse angles, the x value is gonna be negative, and the two things that are affected by the x are cosine and tan. Okay? So, obtuse angles, they're gonna give me negative ratios. Now, how can you find your angle? What do you do to find your angle? If I'm asking you, find your angle. Inverse. Now, here where you have to be careful, because the calculators are, they're programmed, right, to give you one answer, okay? So if you want to inverse 4 over 5, right, what's the calculator gonna give you? What, did you do sine inverse of 4 over 5?
I get 53.
I can't do
53, right? So if you do sine inverse of 4 over 5, find 4 over 5 and do sine inverse.
Yeah, like you divide it first. That's what I do.
Sure, that's fine.
Or divide it by 5 and
Okay.
then do that and then inverse that.
Yeah, that's fine. So what did you get when you did this? But we know that our angle, which is the principal angle, cannot be 53. Now, that 53 belongs to what angle? To my acute one. So that 53 is my supplementary acute angle. And here's where you have to use your brain and your knowledge and not your calculator only. Okay? Because if you do that on the calculator is going to give you the supplementary acute angle.
Yeah, so
In
you have
this
to do
case.
the 180.
So you have to find your principal angle. You're going to have to find the 180 minus the angle.
So 90 minus 53.
Oh,
No,
principal is like the
180.
bigger
Oh,
angle.
180. Oh yeah, you're right.
One at a time, please. Sorry. I know this is so confusing, and that's why I want to hear all your questions. Yes.
Is it always gonna be like that?
What do you mean? Is it always going to be like that?
Where it's
Like,
gonna give
It's gonna
you
be 127.
the
Yeah, it's 1. Because
supplementary
This is
angle?
the supplement.
if you're doing the sine inverse, the calculator is always going to give you the acute angle. Okay? And your job to find the obtuse angle.
Which is like 180 minus whatever.
Exactly.
So I'm just gonna add, so I'm defining angle as minus by the 180.
And that will give you your obtuse angle. Okay? Now in this case, we know that our principal angle is obtuse. So, here's the thing.
Miss, you had me until.
If you don't have a headache, I'll be worried. You should have a headache.
You had me
You're not
until this
ready.
point.
You should have a headache, right? Okay, here's the thing.
It's me kind of get what you're saying.
I like get it, but I don't.
Me get what you're saying. It's like
Okay.
you're saying.
No,
Right.
just give me a second, okay? Sorry, let me just explain that. Listen, if you're in the first quadrant, your principal angle is acute, right? And then your supplementary angle is obtuse, okay?
supplementary, one answer. They're not programmed to give you two answers. Right? Now, if you decide to take cosine, right? Do cosine inverse of -3/5. What does that give you? Do cosine inverse of -3/5. Or find -3/5 and do the cosine inverse.
On this calculator, do I do like this?
100
Yeah.
And then 3 divided by -3.
127.
13 again? I get 26.
127.
Actually use like the fraction.
127?
Yep.
Yes, ma'am.
Okay, is that your supplementary so not supplementary, your principal obtuse angle?
Yes.
Yes. So if you use the cosine, some calculators or most calculators are programmed to give you, if you put a negative cosine, to give you that obtuse angle. Now try tan. What does tan give you? Because I might give you one of these three, and then you have to figure it out. But you need to know. You need to know.
So the principal angle is like the bigger,
In this case, yes. That's what I.
but on the first quadrant, it's the.
Yes, because that's what I just taught you here. No.
Yes.
Yes.
Grade overheat, however.
It's okay. Good.
Ugh.
I love that.
This was supposed to be easier than grade 11.
I got it.
But it's not really. We get what Miss said. Like in a
4
quadrant.
over -3. Yeah.
In a quadrant.
So how about
Yeah. What did you get? -53.
Yes. Negative.
Negative angle now. We're getting into the negative angle. Okay. We're not gonna even bother with that.
How is that even possible?
Okay. Just it is possible because when I have an answer for everything. Because you know how we always measure angle from the x counterclockwise,
So
right?
an
We
angle
measure
would
them
be
this
like-
way.
would
So
be an angle
that
from
means
the
it's
other
right here, but
side.
we don't deal with these angles, remember? So if you go from the x-axis clockwise, that gives you the negative, but we don't deal with that. Okay?
Tell me that wasn't a thing in grade 11. You're like, that's not a thing.
So here's the thing.
For us,
Here's the
it's
thing.
grade.
Here's the thing. When your calculator gives you a negative angle, for the purpose of this course, you're gonna ignore it, and then you're gonna count it as your acute angle. 50%.
But it's positive.
Yeah.
You're just gonna scratch the.
And that will be though your acute angle, your supplementary acute angle,
But without the negative.
without the negative, 53.
You're gonna do it.
But you still have to find your principal obtuse
Yeah,
angle.
180 minus.
Yeah, 53. Okay. So, but why do I want to teach you all of this? Because in your homework, for example, they give you this. They give you tan theta equals to -4/3. What's angle theta? You're gonna get a -53, and then you're gonna come to me. I have a -53 answer. Yes, you do. Ignore that negative part.
For now.
Well,
Shake my
Unless
head,
you-
miss.
unless you want to take
Period.
U-level courses, hard pass. Okay. So remember that when you're reporting your angles here, you're gonna report the acute or supplementary. Acute angle equals to 53 degrees, and your principal obtuse angle as 180 minus 53. What was the answer for that? 127? Feel like you guys are ready to quit?
I'm not quitting, I'm just over it for right now.
You know what day today is, miss?
This